In this video, I'll be talking about stacks. I covered functions and global variables in my previous video, so now we're going to be starting with abstract data types, and the first abstract data type is stacks. So this is a very important part of computer science A-level P4, so make sure you pay attention. So let's start with stacks. Let's start with what exactly is a stack. Now, a stack is used to hold data, and in Python we use arrays to represent stacks. So this is my stack. These are its index positions. So adding a data to a stack is called pushing an element, and removing a data is pop. So these are the two functions that we'll be defining. So first, let's understand the concept of a stack. It uses the principle LIFO, which stands for last in, first out. So when we add a data, we use the push command. So push, I want to enter A, then B, then C, then D, then E. So this is me pushing the data. So first I'll push A, it'll go in the first free space, then B, then C, then D, then E. Now when I want to remove a data, the first data that's going to be removed is E, because it follows the principle last in, first out. So the last element that came in the stack was E, so it'll be the first to be removed, then D, C, E, and A. Now, a stack has something called a stack pointer. So mostly the stack pointer is pointing at 0, which is the first free element. Now, when we add an element like A, our stack pointer moves upward. So when the stack pointer starts at 0, it's pointing to the next free space. When we'll enter B, the stack pointer will go up to the next free space. Same with C and D. When I've entered D, it will point towards the last free space. And when I've entered E, it will go even further. Now, here, how can you tell that your stack is full? When it's pointing at an index greater than 4, any index that is greater than 4 or equal to 5, that means that my stack is full. Now, another scenario can be that my stack pointer is not pointing towards 0, it's pointing towards -1. So for this, when I'll add an element A, then it will go to the 0 index. When I'll add B, it will go to B. So the difference here is that when it was at 0, it was pointing towards the next free space. But when it's at -1, it's pointing towards the data that's just been added. So C, D, E, when I've entered E, it will point towards the 4th index position. So in this case, how can we tell when the stack is full? It's when it's equal to 4. Now, keeping these concepts in mind, let's write the code. First, let's take an array. Let's take a 5-element array. So we have an array and we have a stack pointer. So first, let's make it point towards 0. Then we'll write the function push, and it will take the value that we want to add in the stack. So now, as I'm using array and stack pointer in my function, I'm going to take them as global so I can make changes to them. So the first thing that we're going to do is check if the stack is empty, if the stack is full, or if we can add more elements. The first condition will be if stack pointer is greater than 4, meaning if it's pointing to anything greater than 4, then we will print stack is full. This was the easy part. Now else. Else, we're going to take array with the index stack pointer, and we're going to add the value to this position, and then we're going to increment the stack pointer so that it will move on to the next value. So this is the easiest way to write a code for pushing a value in a stack pointer. So let's print the array first and see what we'll get. So this is originally my stack. Let's push A. Oh. After pushing A, I will print my array again. So here you can see the first it's empty, then I pushed A, and now it has A in it. So let's push B, push C. Now let's see. Now it has A, B, and C in it. Now our stack is full. Now if I enter another value, then it will give me stack is full. So this is how you push an element in a stack. This is how the concept of stacks work. In this case, our stack pointer was 0. As I said, stack pointer could be -1 as well. So how to make changes accordingly? As we discussed over here, when the stack pointer is pointing at -1, our stack will be full when it's equal to 0. So instead of greater than 0, we'll add the condition if it's equal to 0. Now here, array stack pointer is equals to value, and then stack pointer is equals to stack pointer plus 1. So what we need to do here is we're going to take this and write this before assigning it the value. This is because first we need to increment the stack pointer, because originally it's pointing at -1. I need it to go to 0, and then I need to add the value, which is why I need to increment it first and then add the value to the stack. So you can see that this runs the same way. Now let's write function for pop. So as discussed in pop, if it's pointing at 0, so it'll be here, I need to take out E. So when I'll take out E, my stack pointer will move down. So when I take out more elements, it will keep moving down one by one. So let's write the code. I'm going to take the array as global and the stack pointer as global. First, I need to check if there are any elements in the stack, because if the stack is empty, that means that I don't need to pop anything. So let's do this with 0. So if my stack pointer is equal to 0, that means the stack is empty. I don't need to pop anything. Else, so what I'm going to do here is I'm going to assign the value that I'm popping with an empty string so that you can see how it works. Also, I'm going to decrement the stack pointer, and then I'm going to assign it with an empty list. Now, why am I decreasing the stack pointer first and then assigning it with an empty string? It's because Originally, if it's pointing to here and I want to remove D, I needed to come down and then I needed to remove D. So let's see. Now here, if I use the same command. So if I pop once, here it's gonna from ABCDE, it's gonna give me ABCD. If I pop 3 times, it's gonna give me AB. If I pop 2 more times, it's gonna give me an empty string. And if I pop 1 more time, it's gonna give me stack is empty. So this is how pushing and popping works in a stack. In the next video, we're gonna cover queues.